Okay, so all the stuff that we did before, so the reason I said it's probably a good idea if you have questions over anything you missed on the test is because it doesn't go away, like kind of like how algebra just builds on each other, so does trig. And so all of the stuff that we did, with the exception of until the test, until the final, you're not going to see a bearings problem again. But all of the other stuff builds on itself. Sine, cosine, tangent, the reciprocal identities, all of that stuff, it doesn't go away just because we finished that unit. So, you probably get on it. All right, so I'm sure you knew that there were ranges because one of the things that we've had to do is switch our calculator from degrees to radians. And actually, if you second plus 712 your calculator, it automatically goes to radians. Because radians are actually easier than degrees and more commonly used by mathematicians. But degrees are what you learned first. You know, way back in the day when you were like, I think 4th grade, maybe the first time that they put this wonderful thing on your school supply list.
I've never had one of those. We've never had to use those yet.
Chiropractor?
Chiropractor.
Yes, you do. They put it on your school supply list.
I've never had to get
yay,
one.
a protractor. And you don't know what you use it for because they don't teach you what to use it for until like later than that, like 6th grade or 7th grade. But you measure angles with it. Seriously, I think you probably did in 6th grade or so. But you measured angles with a protractor. But when you measure them with a protractor, you measure in degrees, and that's what you learned first. A circle is 360 degrees. You can measure an angle. This is 90 degrees. That's what you learned first. But honestly, radians are easier. So let me explain to you what a radian is, and it'll make sense, and it'll all start to make sense. So if you read right here, it explains. Angles can be measured in radians. A radian measure is defined by the following ratio. The length of the intercepted arc divided by the length of the radius is 1 radian. Let me explain that in plain English. This is my circle that I just drew, and it has a radius of 30 millimeters because that's what I chose when I drew it. So hold on, let me draw the center real quick. Okay, so it has a radius that's 30 millimeters long. So a radian is if I took a little piece of string and got it exactly 30 millimeters long, and then I curved it along the outside and made a mark. So I did that. I made one. So
How do you know that circle has 30?
I used a protractor. I used a compass. I measured this. This is 30 millimeters. So it's like I go like this, and that's 30 millimeters.
Wait, the whole yellow part or just the outside?
Just this outside edge. If I were to you know how you have those things that you can roll on the ground to make measurements that aren't straight? Yeah. If I could do that and roll it right here, that is 30 millimeters, exactly like the radius. Oh, okay. Does that make sense? Yeah. So 1 radian is equal to 1 radius.
Okay.
If you were to roll it around but it's actually, no, yes and no. But what a radian is telling you isn't 30 millimeters. It's telling you how far open the angle has to be in order for that outside edge to equal the radius. Does that make sense?
Oh, okay.
It's like, okay, if I want that to be 30, I have to open this far. If I open that far, it's too wide. So that's what a radian is. Okay. So with that said, if we were to convert a radian to degrees, 1 radian is equal to 57.3 degrees, approximately. That's why it's wavy lines. Which means 2 radians is equal to 114.6. Because you just double it. And 3 radians is equal to 171.9.
Wait, why didn't we double it this time? Oh, never mind. Silly children.
And 180 degrees is pi radians. So, let me show you. What did I do with my little... Where did it go? Oh, I lost my little triangle. my little piece of pie. Dang it. Oh well. Okay. Pretend I still have my piece of pie. Maybe I have the. Yeah, my little yellow piece.
Yeah, you were just using it.
I know. Okay. Under my calculator. Okay, so there's 1 radian, right? That's 1 radian. And if I stick this right here, this is 2 radians. Well, I should have had a straight line. And then I go like this. Not exactly in the center, but pretend I am. Okay. This is 3 radians. But look, I'm not straight across yet. Because straight across would be right here. So it takes 3 radians to get here, but I have this little piece left over. That's 0.14159, blah, blah, blah.
Oh, that's pi.
Yes, that's pi.
Oh, so 3.145. Okay.
Yes. So here, that's what this means.
1.9, I think.
So it takes 3.14159, et cetera, et cetera, et cetera, radians to get 180 degrees.